see, we are going to solve one more problem based on the binomial distribution in the chi-square test. Therefore, the question is, fit a binomial distribution to the given following table over here it is given and test the goodness of fit at 5% level of significance. Therefore, the goodness of test is related to chi-square, and hence we proceed further. So the answer, what should be the answer? So here the experiment is not known. You can see over here they have just given x and f value. They have not mentioned any experiment. Therefore, we have to find the mean first. Because it is binomial distribution, before applying the p of x formula, which is equal to ncx p power x q power n minus x, we have to find p and q. The experiment is not known. Therefore, we have to find some relation in order to find p and q. Therefore, we have one relation np is equal to the mean. np is equal to mean. Now, n is nothing but, here it is given. So always remember, n will take it as 5 because over here it is not given, any data is not given. The experiment is not known. Therefore, we have to take it as 5 for any or only for fitting binomial distribution. Remember this point, we will take it as 5 only for fitting binomial distribution, since the experiment is not known. How many times or how many previous problem we have solved, in that experiment was known 5 identical coins. That means we have taken as 5. But in this case the experiment is not known. Therefore, we will take it as 5. Now mean. How to find mean? Mean, the same formula, which is equal to summation of f into x by summation of f. So summation of f into x you have to do. That means multiply 0 into 2 plus 1 into 14 plus 2 into 20 plus 3 into 34 plus 4 into 22 plus 5 into 8 and add them together. You will get it as 284 divided by summation of f, which is nothing but 100. Just add it up. Add all this thing. You will get it as, so the final answer will be 2.84. So this is the mean we have got. Now we have to just substitute over here. So np is equal to 2.84. n is nothing but 5. So 5p is equal to 2.84. Therefore, the p is equal to 2.84 divided by 5, which will be 0.568. Now for q, what we need to do, just subtract 1 minus p, that is equal to 0.432. So this will be the answer. So we'll just substitute this value. So p of x is equal to ncx, that is 5cx. P of x, what is p of x? P we got it as 0.568 power x. Q we have got it as 0.432 power 5 minus x. So this is the final equation we got. Now we need to just substitute the x values. So x values will be 0, 1, 2, 3, 4, 5. We have to find p of 0 to p of 5. P of 0 means x value will be 0. So you have to find the value of p of 0 to p of 5. Then after that, for finding expected frequency, we have one formula. E of x is equal to summation of f into p of x. That is why we are finding out p of x first. After finding e of x, then we have to check whether summation of f, which is equal to 100, whether it is equal to summation of e. Then only we can go for the magnitude chi-square. So here you can see I have written all the values. P of 0 to 5 we have calculated by the equation. Then for the expected frequency, as I said, summation of f into p of x you have to do. Summation of f is 100 into p of x means, for example, p of 0 you have to take multiply with 100 to get e of 0. Okay, so with respect to this you have to find out. After that we have to check whether the summation of f is equal to summation of e. Therefore, we can see over here the summation of e is 100. Therefore, it is equal to summation of frequency, that is 100. Therefore, we can go for the chi-square formula. So as you can see, I have written the e values as well as f value. This is f1, e1, f2, e2, f3, e3, so on. Now chi-square f1 minus e1, that is 2 minus 1.51 whole square by 1.51 plus 14 minus 9.89 whole square by 9.89 plus 20 minus 26.01 whole square by 26.01. So on you have to do till the last case, that is 34 minus 24.20 whole square by 24.20 plus 22 minus 22.48 whole square by 22.48 plus 8 minus 5.91 the whole square by 5.91. So this is the overall case. So as you calculate all these things, you will get the chi-square value as 4.006. So this will be the chi-square value. So we need to test for the hypothesis. Therefore, we have to find out chi-c-square, that is critical value. Let us go and find out. So chi-square value we have 4.006. For finding chi-c-square, we have to find first the degree of freedom, that is n minus m. So we have number of frequencies 6, frequency pairs 6, m is nothing but here it will be 2, since we have to understand that here we have used one quantity, that is summation of f is equal to summation of e, as well as one more quantity is nothing but mean of frequency distribution. We have found out the mean as well, f of x by summation of f. We have used this quantity also. So you need to remember in which case we have to take 2 and in which case you have to take m as 1. So whenever you get the mean, whenever you have to find mean, that means whenever the experiment is not known, we have to find the mean for the binomial distribution. So we have to take it as 2. So it will be 4. So level of significance, one more factor is there. So it is given in the question 5% level of significance. So therefore it is 0.05. So you have to check the table to find out the chi-c-square value. So as you can see, at degree of freedom 4 and level of significance 0.05, chi-c-square value will be 9.49. This is the value of a chi-c-square. Now we have to check whether it belongs to the interval or not. So for that, 4.006 chi-square value, whether it belongs to minus 9.49 comma plus 9.49. This is the question. Yes, of course it belongs to this interval, therefore we accept the hypothesis. Therefore we can say that, we can conclude that binomial distribution makes a good fit for the given frequency distribution. Okay.